Alright, so we're going to use theoretical probability with combinations to find out the distribution of probabilities of rolling sixes when I've got 4 dice. Okay, so the first thing I'm going to do is to make a table like this. Okay, and when I have 4 dice, what are my outcomes of sixes I can have? I can have 0 sixes, 1, I can get 2 sixes, 3, or 4 in a row. Alright, so with 0 sixes, it doesn't matter what number it is. It's either a 6 or it isn't. So if I roll something like this, it's no different if I rolled something like that. I just want to know if it's sixes or not. So there's only one combination for no sixes. Okay, so I'll write that in my column of how many different ways can I get no sixes, which is just, okay, there's 4 no sixes. And the probability of getting 4 no sixes, well, the probability of 1 no 6 is just 5 out of 6. That's the probability of getting no sixes on 1 die. Well, on 4 of them, I just multiply all of those probabilities together. Whoops. And that gives me my probability of getting no sixes with 4 dice. And I can express the probability, and I express it in 3 different ways. I express it as a fraction, a decimal, and a percent. And I'll tell you which way you want to use depends, but when you compare them, you want to make sure that they're all in the same way. So a combination of 1 6, that means I've got the 4 die, and I've got 1 6. Well, there's several combinations of getting just 1 6, since I have 4 different dice. And I could have something like that. I can have something where the second one is a 6, third one is a 6, or the fourth one is a 6. And what I do is I look at the number of combinations, and that's 4. There's 4 different combinations of getting 1 6. So what I do is I take the probability of one of those, and there's 4 different ways of getting it, so I'm going to multiply that by 4. So I say, let's look at this one right here. Getting a 6 is 1 out of 6, and not getting the 6 3 times is 5 out of 6. And since there are 4 different ways of getting those, I multiply that probability by the number of combinations, which is 4. This one was 1, so I didn't need to multiply that by 1. Okay? I'm going to highlight these guys. Okay, and I've got my probabilities expressed 3 different ways. And just a hint, with probability, it's not going to help you if you simplify the fraction. Alright, so this fraction here can be simplified, but it's best not to, because we can compare these a bit easier when they've got the common denominator. So I can see it's more likely to get 0 sixes than it is 1. Okay, what about 2 sixes? What are all the possible outcomes I can get from there? Well, I can get quite a lot. I can get the first 2. I can alternate it. I can get the first and last. I can get the middle ones. I can get the last 2. And I can alternate again. So 1, 2, 3, 4, 5, 6 different combinations of getting 2 sixes. Now there is a method of calculating this number right here. Okay, but since we're only using 4 dice, we can work it out. 6 is going to be the most number of combinations I get from this. But there is a way of calculating it if I were doing something like 10 dice or something. So this one, I'm going to find the probability of one of these and multiply it by 6. So one of these is 1 6 is 1 out of 6. And another one is 1 out of 6. And 2 no sixes is 5 out of 6 times 5 out of 6 times the number of combinations there are, which is 6. Now I'll work out the probabilities like I did here, and I'll express it in all 3 ways as well. Okay, so 11.6% chance of rolling 2 6s with 4 dice. Same with 3. How many outcomes? Let's put them down. Four different ways of getting 3 6s with 4 dice. So you get the idea from now. Probability times number of combinations gives me my total probability for 3 6s. Okay, so we can see that the probabilities are decreasing as the number of 6s increase. And 4 is going to be like 1, where I only have 1 combination. There's only one way I can get 4 6s, and that's 6 6 6 6. Okay, so the probability of that one is just going to be 1 6 times 1 6 times 1 6 times 1 6. Pretty unlikely, but it can happen. And we get 1 out of 1296. Same denominator as all my other ones. The decimal equivalent of that is pretty low. And I'm going to put this one to more decimal places because it's pretty unlikely. But that doesn't mean it won't happen. So what we have here is the probability distribution for the number of 6s when I roll 4 dice. We can see that 0 6s is the most likely outcome to happen, followed by 1, and then 2, and then 3, and then 4. Okay, so with these probabilities, I'm able to solve probability questions. So we'll leave that up there for a while. Roll 4 dice, see which one I get. No 6s. That's what's supposed to happen. Okay, roll it again. 1 6. Okay. Okay, so here's my first question. I said if you did 500 trials, meaning taking 4 dice and just rolling them, how many times would 1 6 occur? And this is an expected number problem, where the expected number of times for something to happen is just the probability times the number of trials. And the probability for rolling 1 6 times 500 trials, well, we just did all that work. And the probability of rolling 1 6 is 0.386. Okay, pretty simple work, but getting this far took all the time. And I worked that out on the calculator, and I get a nice whole number where I don't have to worry about rounding. It should happen about 193 times. Okay, and if there was a decimal there, we want to round that to the nearest whole number, because when I'm asking about how many times something should occur, something's not going to occur at 193.3 times. So whole number. Okay, next question. Suppose I want to find the probability of rolling 2 or more 6s. Well, the probability of rolling 2 or more 6s means the probability of rolling 2 6s plus the probability of rolling 3 6s plus the probability of rolling 4 6s. And I've worked all this out. Okay, I've worked all this out right here. There's 1 6, there's 2 6s, there's 3 6s, and there's 4 6s. So it's the sum of all of those probabilities, 1, 2, and 3. So 2 6s was 0.116 plus 3 6s was 0.015 plus 4 6s, very unlikely, but still put it down. And we grab the calculator, and I get about a 13% chance of rolling 2 or more 6s. All right?